Hello, welcome to FCS 5901, Basic Statistical Terminology. I'm sure since that you've had research methods that some of these terms are going to be familiar to you, but we do want to touch base on them as we use them in statistics as well, and it's important that everyone is on the same page. So, a population is an entire group of observations that somebody is interested in studying. So it is the entire group, every single person that could possibly exist within a group that you're considering. So if you're considering a research project with pregnant American adolescents, then it would be every single one is in the population. Since it's nearly impossible to research every single person in a population, then we have samples, and that's a subsection of the population. So in like the example below, if you're interested in studying Eastern students, all of them comprise the population, but is it feasible to study all of them? No. So you need some kind of subsample, but it has to be representative of the population you're studying, or your findings aren't going to be relevant to the population or even applicable to the population. So how do you do that? Well, these demographics were taken, I believe, last year for EIU. At the time, there were 9,975 students in total. 60% were female, 40% male, 72% were Caucasian, non-Hispanic, 16% were African American, 4% Hispanic, less than 1% were Asian, less than 1% were American Indian, less than 1% were multiple ethnicity and international, and then 2%, I'm sorry, I'm reading these backwards, international were actually 2%, and then 3% didn't report anything. So your sample, you would want to be as representative of this demographic as possible. The average age is 22 years, so you would want to make sure that the sample that you get matches this, not perfectly, of course, but comes close to it. So if you had a sample that was comprised of all males and the average age was 19, and they were all or mostly African American with some Hispanic, that would not be representative of the EIU population, and thus the findings that you would get from that study may not be applicable. So again, when you're thinking about a representative sample, and I know we're looking at EIU students, but of course there are many populations, you have to take demographic variables under consideration. So things like gender, age, ethnicity, depending on what you're studying. If you're looking at parenting, you would need to make sure that your subsample contains parents. Otherwise, what's the point? So you have to think carefully about your population and then try to find the representative sample. And it doesn't have to match it completely, but it should be a good representative of the population. When you are selecting a sample, there are actually several choices to choose from. There's a probability sample, and then there's a non-probability sample. A random probability sample. Hold on one second. Okay, so the dance video helped to illustrate standard error and how there can be a lot of variance in a sample compared to a population. It may not exactly match, and that's why it's important to know what kind of sample you have or how you collected it, how you determine what kind of sample you have, and then you would also note the limitations to that. So it may not be applicable to the entire population. It may not be representative of the entire population. but due to time constraints, due to costs, etc., that was the sample that was chosen, and that's what you went with. And that's okay as long as you're upfront about it. So these factors, I just mentioned them a second ago: time, cost, feasibility. For the purposes of your class projects, you don't have a lot of time. You don't have any money at all unless you're willing to put your own money in. And it has to be feasible. You have to be able to do this, gather data within the time period for the class, which is 6 weeks. So you don't have a lot of time, and you want to think about who actually you could get to participate in a study, fill out a survey for the purposes of the class project. Okay, the independent variable versus the dependent variable. This isn't too much of a concern unless you're conducting t-tests or ANOVAs. And it's important to note that if you're conducting a correlation, you're not establishing any causality. And so it wouldn't matter which one's the IV, which one's the DV, or IV being independent variable, DV being dependent. And statisticians like to use multiple words for the same thing. So independent variables are sometimes called predictor or predictive variables, and dependent variables are sometimes called outcome variables. The way that I like to think about it is independent variables. I'm sorry, let me start that over. Dependent variables depend on changes in the independent variables. So the dependent ones are dependent upon something, independent are not, they're just out there. That helps me to keep them straight. So again, if you're conducting correlations, it just means that two variables are related. We'll talk specifically about correlations later in a separate PowerPoint. But just know you can't establish causality with just a correlation. You have to conduct the correct type of statistical analysis. And causality just simply means one variable has an effect on another or causes something. So again, the dependent variable is dependent on changes in the independent variable. So the dependent variable in these examples are car accidents in graduate school. And what we're saying is that changes in weather can cause car accidents, and changes in GPA affect whether or not somebody's admitted to graduate school. There are other examples here. There are 3. Whoops, knocked over my microphone, sorry. If a study is seeking to determine whether or not heavy metal music causes adolescents to become more violent, then the independent variable would be the music, the heavy metal music. The dependent variable would be the violence. If a group of researchers is looking at the effects of long-term poverty, they do this by studying subjects' physiological health and attachment to the workforce. The long-term poverty comes first because that starts in childhood, so that would be the independent variable. The dependent variables, there are 2, would be physiological health and attachment to work. And then the last one is kind of a tricky one. Does self-esteem increase as a result of getting good grades on tests, or do good grades cause higher self-esteem? And it could go either way. And this can be the case for a lot of different examples, and even something you may be studying, and that's fine. You just have to state the way that you are measuring it. So if you do plan on establishing causality through using t-tests or ANOVA, you do have to explicitly state which one's the IV and which one's the DV. And even though they could be interchanged, you determine what you're doing and go with it. Okay, data sets. We'll all be working with data sets. We'll be working with it in class. We'll be working with it with your projects. You'll be working with it on exams. A data set simply looks like this. And I'll come back to that in just a second. A datum is a single piece of information, and each datum is called a variable or even an item. So each item on a survey, and the item could be a statement, it could be a question, is considered a variable, and when it's entered into a data set, it's considered, each single piece of information is considered datum. So you would typically set up a data set similar to this, where you give a name to and describe the variables at the top row. If it is a Likert type scale, you want to put in parentheses, like I have, what low numbers mean and what high numbers mean. And you could even code, if you wanted to put the codes that you determine for year, ethnicity, you could put those in parentheses or underneath a variable name. You can do whatever you want. But you would at least have to keep a code book to determine how you're coding Caucasian, African American, Hispanic, and how you're coding year in school. Because data doesn't come to us in numeric form in all cases. I mean, with age, yes, we're getting a number. And with the Likert type scale for relationship satisfaction, we get a number. And that's entered into Excel, just as so. But for other types of variables, which we call categorical variables, you don't have a number. You have to assign one. And so you might code red, so you're asking what is somebody's favorite color. Red is coded as 1, blue is 2, yellow is 3, green is 4. And these numbers don't have any meaning, which means your peer could decide to switch the order and code green as 1, blue as 2, red as 3. It doesn't matter. The order makes no difference. You're just assigning numbers so you can enter it into Excel. So if somebody indicated blue and we're coding that as 2, and then they indicated Caucasian and we're coding that as 1, because we assigned that number, that very first row, you'll see then that you would enter 1 for ethnicity and 2 for color. And that you need all of your data to be in numeric format so that you can analyze it. We can't analyze words, not for a quantitative data analysis. Again, each of the items are questions on a survey, each of the statements or questions on a survey are considered items or variables. But you'll hear items like items 3 through 6 measured. Studying habits, that just means that the statements or questions numbered 3, 4, 5, and 6, those are the items. And sometimes you can take items together and add them up to create a total score. So let's say you had 3 questions that asked how often somebody engages in a certain type of study habit. So the first one is taking notes, the second one is highlighting notes, the third one is reading, and all of them are coded where a higher number, actually they could just be, you could do it by like how many hours. So higher numbers would mean more, of course, and lower numbers would mean less, and you could tell Excel to sum those 3 items to create an overall score. You don't have to do that, but that is something that researchers do. Reliability and validity, let's just talk about this very quickly. I do expect in your projects that you are going to add a sentence or 2 about reliability and validity. So reliability, is it reliable? Do people perform in a similar manner if they're given a survey multiple times? And then validity, does it actually measure what it's supposed to measure? And so on the next page we have a measurement of self-esteem. And if you were to look at this, if we were in class, I would ask you, what do you think this is measuring? Almost always a student identifies self-esteem right off. And I say, yes, that's because the measure is valid. So we have face validity. When you look at it at face value, you can see what it's measuring. If I told you that this was a measurement of relationship violence, you might be inclined to say, I don't think so, Dr. Moyer, because it doesn't look like that. The items don't appear to be tapping into relationship violence at all. Hopefully that makes sense. And the reliability, so again, if you give somebody a survey, you expect them to perform in a similar manner. If you're looking at this self-esteem, it shouldn't change too much. If you do have a measure where you think people's answers would change drastically from day to day, it wouldn't be considered reliable because you want them to perform in a similar manner. And then we have p-value, which is probably one of the most important statistical terms in this class. P-value is sometimes called alpha, and it is a number that is calculated to determine whether findings are considered significant. And when we use significant in statistics, we mean something very specific. We're talking about, can findings be attributed to the variables that were measured in this study, or could they be attributed to chance or luck? And if you have a p-value of 0.05 or less, then that makes it less likely that the findings can be attributed to luck or chance. So you want the p-value to be small, and you want it to be less than 0.05, as that is the accepted cutoff in social science research. And what does that mean? If you have a p-value of 0.04, it means that there is a 4% chance that the findings you got can be attributed to factors you didn't even measure. And we refer to that as chance or luck. Alternately, if there's a p-value of 0.17, it means that there's a 17% chance that the findings are not significant, and then they can be attributed to other factors or chance. And so you want a lower number, and 0.05, then we say it's a significant finding. You can Google p-value if it still is confusing. You may have heard it before. I'm not sure what your exposure has been. But you do have to have a good handle on that. You need to know that 0.05 is the magic number, and you need to know that when it is 0.05 or lower, that it's a very low chance that the findings can be attributed to chance. Finally, there are two kinds of variables in statistics, and I understand you probably talked about ordinal and nominal, ratio, etc. in research methods, but for the purposes of statistics, that doesn't really matter here. What does matter is whether it's continuous or whether it's categorical. If it's continuous, you can think of it as coming to you in numerical form in a natural way. So, like Likert type scales, if it's a scale from 1 to 5, you get a number. Somebody circles 2, that's the number you put in Excel. So that comes to you in a numerical form. Age comes to you in a number, height, weight, GPA, length of relationship, number of children. You wouldn't want to make these into categories because they are naturally continuous variables, and you can do more with continuous variables versus categorical. And the numbers have meaning. So if somebody circles a 2 on a Likert scale and it's rated from 1 to 5 on likability, 2 meaning not likable, then that has a meaning. Categorical variables are, like we talked about before, with having to assign numbers, and those numbers don't have any meaning. So when we were talking about favorite color, and I said, the next person could code red as 2, the next person could decide to code red as 4. That's because the number doesn't have any meaning. It's just a number to help you enter it into Excel and conduct an analysis. So categorical variable examples: gender, hair color, location, major, occupation, etc.